Good morning. Welcome to Mission Control Houston, the home of the International Space Station Lead Flight Control Team. The Orbit 2 team of flight controllers is on duty this morning, helping Expedition 56 Commander Drew Feustel and his crewmates through the last few hours of their work day on orbit. The astronauts and cosmonauts are looking forward to a full weekend off duty after having been busy last weekend with the arrival of 3 new crew members, and then completing the first spacewalk of this increment yesterday.
Houston Station on Space to Ground.
Drew Feustel has now moved into third for all time spent spacewalking. Feustel now on his 9 spacewalks has spent 60 hours, 22 minutes and counting outside in the vacuum of space.
Welcome to Space to Ground. I'm Catherine McLaurin. This week, the crew kept busy inside and outside the International Space Station. Expedition 56 Commander Drew Feustel and Flight Engineer Ricky Arnold completed a spacewalk on Thursday. The astronauts installed new high-definition cameras near an international docking adapter attached to the front end of the station's Harmony module. The new cameras will provide enhanced views of the final phase of approach and docking of the SpaceX Crew Dragon and the Boeing Starliner. Dragon and Starliner are both commercial crew spacecraft that will launch soon from American soil. The astronauts also had time to swap out a camera assembly on the starboard truss of the station and close an aperture door on an external environmental imaging experiment outside of the Japanese Kibo module. 5 hours and 23 minutes into the spacewalk, Feustel moved into third place for cumulative time spent during spacewalks, surpassing Peggy Whitson, who previously held that post. Did you know that the NASA Periscope channel offers more chances to interact with NASA astronauts, scientists, and engineers? This week, the NASA Periscope channel hosted a special event where Joe Acaba and Mark Vandehei talked about the National Week of Making, STEMonstrations, and the Year of Education on Station. People were able to tweet their questions to @NASAEDU using the hashtag AskNASA before the event for Joe and Mark to answer live. For your chance to participate in future events, be sure to subscribe to the NASA Periscope channel. This week's question comes from Claire from Sturgeon Bay, Wisconsin, who wants to know if being in space is just like being underwater. Well, it's pretty close. Astronauts train for spacewalks at the Neutral Buoyancy Lab at the Johnson Space Center. The lab is essentially a big pool with a full-size mock-up of the space station in it. Astronauts train underwater to practice for future spacewalks. Being underwater is an excellent way to prepare for the microgravity environment of space because you can be weighed so that you are neutrally buoyant, which just means you won't sink to the bottom or rise to the top. This is critical for learning how to successfully accomplish tasks during the real spacewalks. Keep sending in your questions using the hashtag #SpaceToGround, and we'll see you next week.
Off the Earth, for the Earth. Space to Ground.
Although your calendar says this is 2018, it is also known as the Year of Education on Station, which NASA has planned as a time to help teachers and their students get the most out of learning about science, technology, engineering, and math. The International Space Station crew members have been talking directly with students on the ground, and they've also been making fun instructional videos in zero-G. In this new installment of the STEMonstration series, Scott Tingle demonstrates the orbit of the spacecraft and offers the viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft orbiting Earth, like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
Providing benefits to people on Earth is one part of the mission of the International Space Station. Serving as a one-of-a-kind laboratory for scientific research is another, and so is helping us prepare for future human exploration of space. But the rodent research experiment covers all of these. Rodent Research 6 is a twofold investigation into the treatment of muscle loss in spaceflight, which may have implications for people on Earth with muscle-wasting diseases. The experiment will study the effectiveness of a drug compound, as well as the nanochannel drug delivery implant.
We're testing the drug as well as the device. Sarcopenia or muscle wasting is a big burden on the healthcare system currently. So the results from this study will provide us with valuable information on understanding the mechanism of action for the drug that we're testing. Now, the other unique aspect of it is the nanochannel delivery system that is implanted in the mice.
These nanochannel membranes are microfabricated with the same type of technology that you use for make computer chips. Because we have realized that if we take channels that they are that small and we use them as a rate-limiting membrane, we can achieve a very steady and controlled delivery of the drug without any sort of pumping mechanism on board of our implants. So that makes a very small, very effective implantable delivery system.
The big goal is that we're making humanity better and we're helping our generation and the next generations live longer and better. So at the end of the day, if we can accomplish that, it makes it all worth it.
On top of experiments in a range of scientific fields, the International Space Station also serves as a test bed for technologies that'll be needed to support future voyages of discovery out into the solar system. That includes systems that'll be needed to complete technical tasks, as well as the systems that'll be needed to support the human explorers and make sure they can survive the harsh conditions of space.
The sweet smell of life support. Presented by Science at NASA. When NASA astronaut Kjell Lindgren blasted off from Kazakhstan in July of 2015 for his first expedition aboard the International Space Station, he had some lofty expectations.
I was eager to see Earth from space, and I couldn't wait to float in microgravity.
And he confessed.
I kind of expected the International Space Station to smell like a locker room.
After all, what would you expect? It's an airtight spaceship continuously occupied 24/7, 365 days a year by as many as half a dozen hard-working and exercising astronauts. Lindgren was in for a surprise, however.
The air in the space station actually smelled great. The filters and the life support system do a great job cleaning the air. There were no issues at all.
First contact with the space station's clean air reminded Lindgren, a flight surgeon, of the impressive technology underlying the station's life support system.
On the International Space Station, we're testing technologies that will allow us to live comfortably during long journeys into the solar system. Our life support systems provide a properly pressurized atmosphere with the right amount of oxygen. It scrubs carbon dioxide from the air, it keeps the temperature in a comfortable range, and provides fresh water and light and everything that we need for good hygiene.
Hence, the sweet smell of the air.
While I was on the International Space Station, I felt a lot like a bridge builder, helping to pave humanity's path to Mars.
As mission planners look toward the red planet, we are definitely evolving from the lessons learned on ISS, says Molly Anderson, a principal technologist at NASA. We want to increase the level of recycling wastes beyond what we do on the station now. Our ISS water system can recycle about 93% of the wastewater back to clean water. The leftover fluid is referred to as brine, and we're flying a demonstration technology on station soon that will recover most of that water too. On the station, if all the systems are working, we can recycle a little less than 50% of the carbon dioxide back into oxygen. We're trying to get that number much higher, to at least 75%, and even up near 100%, she continues. While the space station still relies on cargo vessels to bring fresh supplies and equipment, improved life support systems can help reduce those needs, leaving more room for science and science equipment going to the station. Plus, Earth won't be able to help on missions that leave Earth orbit.
Hundreds of millions of miles from Earth, no one will be able to bring us fresh water or replace malfunctioning systems. We will be on our own, just us and the life support system.
That's why it is crucial for life support development to proceed aboard the station, an excellent testbed for future deep space flight. For more from the International Space Station, go to www.nasa.gov/station. For more news about the sweet smell of spaceships and the systems that support them, stay tuned to science.nasa.gov.
The microgravity in Earth orbit makes the International Space Station a one-of-a-kind spot for scientists who want to find out how natural forces function without gravity's influence. Well, in this Speedy Time segment, astronaut Jack Fisher uses a few simple tools to demonstrate what happens to water in space when there's no pull of gravity.
Today we're going to look at one of the coolest parts of having experiments on the space station. It's because we can separate one of the most dominant forces, gravity, on a lot of different models. A great example is water. Water is pretty much dominated by gravity on Earth, but there's other forces at work that if we understand better, we can have a better model and make greater discoveries. Things like surface tension, capillary action. I'm going to show you today by taking this wonderful bottle, repurposed from a condiment, and blowing into it. When I displace the fluid with air, it will come up the straw and cover my face.
The Dragon and Cygnus cargo ships from SpaceX and Northrop Grumman, which deliver supplies to the International Space Station, are the result of a NASA program designed to help commercial industries get involved in spaceflight and space exploration. For another example, take a look at Alpha Space, the company responsible for developing the Missy flight facility.
Alpha Space was formed in 2015 and really is a product of this new commercialization in low Earth orbit. It was formed specifically to create a commercial payload that would be available in space for private industry. The Missy dates to the early 2000s, was the first mission. It's been utilized by NASA, by the Department of Defense for different experiments. And then around 2010, NASA put out a call for ideas to privatize portions of the space station. And so we responded with a proposal to that, and that's how we ended up with our cooperative agreement. For material scientists who want to test their materials or components in a harsh environment, the Missy platform really offers the most harsh environment that's available, and that's external to the space station. Previous Missies were one-time use, sort of suitcase style. They would open up and expose these materials to space. The Missy platform is a permanent platform that's all robotically serviceable, commandable from the ground from our operations center here. We don't only test materials, we can also do technical demos, we can test circuitry, computer boards, cameras, and its serviceability and changeability allows science to continuously happen for 10 years going forward. Every day, new commercial companies are coming into the fold of this new economy that's developing. I think the space station is a great platform to start commercialization, and I think platforms like the Missy are going to drive a new demand in space.
The International Space Station is designed to assist in the development of systems that will be needed for future human exploration of space. NASA's Human Research Program is working on research and technology development on some systems that will enable people to live and work safely and effectively out in space over long periods of time. One of the most challenging aspects of this work, of sending human beings out beyond Earth orbit, is dealing with space radiation.
For the journey to Mars, the Human Research Program works to project, assess, and solve the problems that astronauts have in space. Specifically for radiation research, the Human Research Program works to predict and mitigate the health effects of space radiation on astronauts.
I think one of the most challenging parts for the journey to Mars in terms of the humans and not necessarily the technology to get there is the risk of radiation exposure and the in-flight consequences of the exposure to radiation as well as the long-term health consequences of exposure.
There's two parts of radiation we have to protect the crew from. One is a solar particle event, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew than had it gone through other materials. So we try to design the spacecraft out of materials that shield the crew from these, but also do not produce more hazardous particles as a function of being impacted with it. So a lot of people think that radiation will keep NASA from sending people to Mars, and that's not what the current situation is. We have techniques, we've discussed ways of getting there faster. We know that we add these various mitigations up, that we can have a successful Mars mission, a healthy crew, and have them live a very long and productive life after they return to Earth.
Along with scientific research and promoting international cooperation and commercial participation in space, the International Space Station mission is designed to enable missions of the future, the ones that'll take human explorers into deep space. The Flight Analogs project of NASA's Human Research Program contributes to the preparation for those missions by simulating the confinement and isolation of a ship in space to learn what it'll take to support crews on extremely long missions. Here's a look inside the habitat to see what supports 4 volunteers during a 45-day-long test.
We can simulate what it is like to be in a spacecraft. So the isolation, the confinement, the controlled environment. The research investigations are aimed at answering some of the questions that we need to answer before we send people on those extremely long duration missions, such as to an asteroid or to Mars. It's probably about the size of, I'll say maybe a one-bedroom apartment that's not terribly luxurious. But on the other hand, it emulates what you might see in a spacecraft. A lot of the things that you have on the first floor are things like workstations. You know, some of the computer and some of the simulation devices are on the first floor. We have a lot of capabilities for performing different kinds of experiments. The second floor, it's kind of like your living room. There's a table that the crew members can sit at and eat their meals. All of our food right now is coming from the Johnson Space Center Food Lab, which means it's the same food that goes to the International Space Station. There's also a capability for them to play videos or to watch movies. We have a couple of exercise devices, a bicycle in particular, and then we also have some free weights. We find that a lot of our crew members will also do some calisthenics, some stretching, maybe some yoga. So there's a tiny little place for them to be able to do that. The final level, if you will, is really not a full story. It's really the sleep quarters. It's bigger than a pup tent. Each crew member has his or her own sleep quarters. It's actually very cozy, very comfortable. The hygiene module has a flushing toilet. We have a stand-up shower with hot and cold running water, and we also have a sink with hot and cold running water. The final element of the module is a very small module that is an airlock. And we do isolate or subdivide the crew such that 2 crew members will go into the airlock, and that is where they'll do their virtual reality EVAs from.
I'm excited for the challenge. I love a good challenge. I'm a professor at Grand Valley State University. I teach biology. I feel like I'm actually playing, it's a small role, but it's a real, tangible, important role in getting people to Mars. The first thing I saw about this was on a Facebook posting, and a couple of former Hera crew people had posted that they had just come out. I didn't think I would be selected, and I just kind of did it on a lark, and it worked out awesome. They are measuring us in more ways than I could have imagined. We've given a lot of biological samples of various types. They're measuring our heart rate, our brain waves. They're doing a tremendously large number of psychological tests on us.
This mission, the crew members are going to an asteroid. So while they are on their way to the asteroid, they are going to practice their flying skills. Once they get to the destination, they're also going to be conducting some virtual reality EVAs. So on the way there, they're also practicing those skills. We have the housekeeping tasks for them. We have maintenance types of tasks. A primary purpose for the mission controllers is really to ensure the safety and well-being of the crew members who are inside the Hera, to make sure that everything is going well. But it's really also to, as much as possible, to keep all of the scientific investigations happening as they're scheduled on time, to answer any kind of questions. We provide some input, a newspaper, if you will, electronically to the crew members in their, I'll call it their morning mail. Not allowing the internet access really does allow us to keep the crew members really engaged in the mission and not to be, concerned about things that are going on in the outside world. The one little luxury, if you will, that they have is approximately once a week, we schedule them for a private family conference. So a telephone call that is patched in on a private phone line. We do plan to keep the Hera operating for at least another 4 or 5 years. The 45-day missions, we're always going to be looking for qualified crew members to be able to come and join us and participate in the research studies.
The International Space Station has been humanity's outpost in space for nearly 2 decades, hosting astronauts from around the globe working on groundbreaking science to push the boundaries in a variety of fields. NASA astronaut Randy Bresnik sought to capture the beauty of the immense spacecraft amidst the tangle of cables and hardware in a series of photos taken during his long-duration mission last year. Here's his argument for the International Space Station as art. If you'd like to get another look at any of the stories we featured today, check us out on YouTube and on Facebook. You'll get a look at these stories and all the other great stuff you can find there about NASA and America's human spaceflight program. And if you're interested in good conversation about space exploration, check out Houston, We Have a Podcast, which features folks here at NASA talking about their work and their experiences on the job. We post new episodes on Fridays. Today, June 15th, my colleague Dan Hewitt talks with Kathy Leaders, the manager of NASA's Commercial Crew Program, for an update on progress toward launching astronauts to space on spaceships built by American companies from launch sites in the USA. Go to www.nasa.gov/Johnson/HWHAP. Houston, we have a podcast. All the episodes are there. You can also listen on iTunes, Google Play, and SoundCloud. This is Mission Control Houston.